Now dear student, we are going to discuss question number 4.3, and in this question we have to pick a vector quantity from the following list. Clear? So now we can see, and let's choose one by one and let us try to understand which physical quantity is a vector quantity and which one is scalar. Clear? So now first if we talk about temperature. Temperature is what? We can say temperature is a scalar quantity. So I am writing here scalar and I am writing here vector. Clear? So definitely we can say temperature is a scalar quantity, because let's suppose if you are saying temperature of this room is 37 degrees Celsius, you are getting a complete information, because 37 is a magnitude and degree Celsius is its unit. Clear to you? Let's suppose you are saying 0 Kelvin. So 0 is a magnitude and Kelvin is unit. So we do not need any direction to specify this physical quantity. Clear to everyone? So we can say here temperature is a scalar quantity. Clear to everyone? Now if we talk about pressure. Clear? Now you can say, sir, what is pressure? Sir, pressure is that thing that always always arises in our mind whenever we are going to study. Clear? So that is not an exactly pressure, my dear student, that is stress. Clear? Pressure is actually defined as external force acting per unit area. Clear? Or we can say pressure. Now you can say, sir, pressure we have seen in mechanical properties of fluids. Let's suppose we have this container. Let's suppose here we have a bowl. Let's suppose cricket ball. So definitely we can say fluid element is exerting a force that is perpendicular to this surface. Clear? And let's suppose if we divide this force per unit area, we can say this is pressure. So sir, is there any wrong in it? Yes, definitely this is correct. Yes, pressure is defined as force per unit area. So you can say, sir, let's suppose if I write value of pressure, for example I am writing 5 Newton per meter square, or I can say this is 5 Pascal. So you can say, sir, this is having magnitude, this is also having unit, but this is also having direction. Why this is not a vector quantity? Pressure is not a vector quantity because it does not have any specified direction. Yes or no? Because you can say the force is acting from every side. We cannot take a particular specific direction of a pressure. Yes, that's why we can say although it is having direction but it does not have any specified direction. So we can say we can put pressure is also in a scalar category. Although pressure comes into category of a tensor. Clear? But tensor you will learn in the higher classes. So here you can put pressure in a scalar quantity. Clear? Now if we talk about impulse. Now dear student, do you know what is impulse? Do you know what is impulse? Yes. So if we talk about impulse, actually if you know impulse momentum theorem, definitely you will learn in a chapter number 5 laws of motion. Impulse momentum theorem says impulse is equal to change in momentum. What I am saying to you, impulse, this is equal to change in momentum. Change in momentum. Clear? So now we can write like this, impulse. Let's suppose if I define impulse by I, or actually it is also defined like this. We can say impulse. Impulse is actually what? When a large amount of force is exerted for a very short interval of time, we can say that is impulse. Clear? Let's suppose your friend slaps on you. Clear? At that time you can say, sir, that large force is exerted for a small interval of time. So we can say this is impulse. Clear? And this is equal to change in momentum. Clear everyone? Yes. So we can say change in momentum. Change in momentum is defined as m, we can say delta v. Clear? We can write like this. This is defined as m v final minus v initial. Clear? Now you can say here we have, this is velocity, final velocity minus initial velocity. So we are getting here the difference of velocity, means we can say velocity is a vector quantity. So we can say impulse, this physical quantity is also a vector quantity. Clear? So we can put impulse is a vector quantity. So actually objective of this question is completed. Pick out the only one vector quantity. So correct answer we have impulse. But as I already told you, let us try to solve, or let us try to analyze each physical quantity. Clear? Let's suppose if we talk about time, definitely our answer is already here, impulse. It means time is a scalar quantity. Now you can say, sir, time, let's suppose if I saying 5 seconds. So 5 is a magnitude, second is a unit, and I know time always flows from past to present, then future. So time is also having a direction, but my dear student, you cannot say, we cannot define the direction of a time from future to present to past. Clear? So actually we are not defining this time. Actually this direction is defined by nature. Yes or no? So we can say time is also comes into category of scalar. And if we talk about power, my dear student, power is actually defined as a dot product of we can say power is defined just a minute. Actually power we can define as the rate of doing work. Clear? So rate of doing work means we can write W by T. Now we know work done is a scalar quantity, time is also a scalar quantity, so we can say power is also a scalar quantity. Clear to everyone? So we can say yes, this is scalar. Now if we talk about total path length, total path length is actually known as distance. Clear? Distance means we can say this is a scalar quantity. We are not taking into the direction into consideration. For example, let's suppose if I am going like this, let's suppose I put here 5 steps, then I am taking this turn and I am putting here 2 steps more. So I can say I total completed 7 steps. Clear? I am not taking care of a direction, that I am just going in a straight line and again I am taking a U-turn. I am not taking it into consideration. Clear? That's why we can say total path length, it is also a scalar quantity. Clear everyone? Yes. Now if we talk about energy, actually energy is what? It is the ability to do some work, or we can say work is already is scalar quantity, energy is also scalar quantity. It means you can say, sir, kinetic energy, potential energy, all these energies are scalar quantity. Yes, my dear student, if we are talking about energy, any type of energy comes into the category of scalar quantity. Clear to everyone? Yes. Now if we talk about gravitational potential, you will learn in the chapter number 8 of gravitation that gravitational potential is also a scalar quantity. Clear? And one more important point I can add here, whenever we are talking about scalar quantity can be positive, it can be negative, because we are just talking about magnitude. Clear? So we can say gravitational potential, this is also a scalar quantity. Clear to everyone? Yes. Now we are going to discuss coefficient of friction. In chapter number 5, laws of motion, whenever we discuss about friction, you can see coefficient of friction is defined as the ratio of F by N. Clear? So we can say this force, this is the force acting, so we can say this is also in Newton, and this is normal force, this is also in Newton. So you can say here you will find this coefficient of friction, it's just a ratio. Clear? You will find this value like the 0.4, 0.3, 0.2. Clear to everyone? And this ratio does not have any unit. Clear? So we can say this is just a ratio, this is not a scalar quantity, not a vector quantity. Clear? If we talk about charge, let's suppose if I am saying to you, we have a conductor, and in a conductor total 2 coulomb charges is flowing. So whenever I am saying charge 2 coulomb, means I can say 2 is a magnitude, coulomb is a unit, so I can say this is also a scalar quantity. Clear to everyone? So now we can say, I can write here charge, it is also a scalar quantity, and coefficient of friction is a ratio. Clear to everyone? So only one physical quantity, that is vector quantity, this is impulse. Clear to everyone? So this is all about this question.